This is an example of a crawl space and a retrofit that has a particular challenge. And what that is we need to attach the end joist to the mud sill with some framing anchors. So the framing anchors would normally, go in right here, some L90s or something like that. However, there's this floor joist in the way. So this floor joist right here makes it impossible to reach one's hand in there with a palm nailer and put in the hardware. It's just simply in the way. So the solution here was to put a ledger right underneath the joist right here, and then bolt the ledger to the foundation, and then take these framing anchors right here and connect the joist to the ledger, and then therefore attach the floor framing to the foundation. Installing these ledgers is very problematic, and the reason being that this foundation really needs to be vertical. If it's not vertical, if it's pushed in at an angle, this hardware simply won't fit. So that's a critical thing. Now the other thing is the foundation needs to be smooth. So let's say a form broke out or it's trapezoidal or something like that. This system just doesn't work very well. So, and it's also extremely labor intensive. So imagine taking this piece of wood, it probably weighs 50 pounds, and you have to drag it 48 feet from a rear access underneath the house to the front. They're always on the transverse walls, so they'd be on the front and on the back. So you have to drag it all the way over there. Then one guy gets on this side and lifts it up. The other guy gets on this side and lifts it up. And then there's a guy in the middle who bolts everything together. That's very labor intensive. You're probably looking at, I don't know, 8, 9, maybe even 10 man hours, depending how complicated the access is. Now contractors have developed another way, and that way all they do is they cut out the joist, as similar to what you see right here, and that way they can reach their hand in, they can put the hardware in that they need to, they can put in the type A connectors, and it's just a standard retrofit. I'd like to show you why that is possible. If you look at these floor joists, they're always 16 inches on center, they're always 2x8s or 2x10s, and you can go 24 inches on center and be 100% American Wood Council Code compliant if you put them 24 inches apart. So 16 inches from here to here, so let's say it's right where this joist is. Then we go 8 inches beyond that, we're right at 24 inches. Now the problem happens when there's a joist comes right here, then it comes over here, and then you've got, I don't know, maybe 3 or 4 inches between the face of the foundation and the side of the joist, and then that's when it's hard to get your hand in there. So if you cut this out, that's still going to be fine, because if you cut this out, you maybe cut out 4 inches maximum, you're going to have 11 feet 4 inches of 2x4 supporting the floor. And in addition, you'll have this joist right here. So you have this joist with a hole in it, and you are allowed a span of 24 inches. So with the 24 inches on center holding it up, the center joist holding it up, you're in pretty good shape at that point. Now the other thing is this old lumber is 2 inches by 8 inches, and that's considerably more volume of wood, and therefore you get a whole lot more support. And right now I'm going to show you how that works out. Right now I would like to look at the impact of wood volume on this retrofit. This is the floor joist. So this is a girder, goes down the center of the house. These are floor joists. They're 16 inches on center. We always find 16 inches on center, either 2x8s or 2x12s. Now sometimes in your 2 stories there won't be a center one here, there will be a center one here, and then there'll be an intermediate one here, and then an intermediate one here. So these are, the spans, they're not overspan, that's for sure. So if we go with these 16 inches on center, 16 inches on center, and then we come over here to the end of the foundation, we're probably at about 28 maximum between this joist and this at the end, and the end joist, assuming this joist ended up where it's in the way. So if we could remove that joist entirely, that would mean if we cut holes in it, we can notch it, we can do anything we want. If we could cut holes in it and still be 100% code compliant, we'd be in good shape. So if you look at nominal wood, and it's a 2x8, 11 feet 4 inches, which is what the span is, and then you do the math, 1.5, 1.5 inches to 7 1/4, you get 1,479 cubic inches. So that's the volume of a nominal 2x8. Now if we come over and we do the rough 2x8, which is what these houses are made out of, we end up with 2,176 cubic inches. Now that's about a 33% increase. So if you just interpolate, you should be able to have the joists, maybe 28 inches apart, and still be code compliant. So we can go from 24 to 28 because the wood is such high quality. And that way we can notch it, we can put holes in it, we can do whatever we need to do in order to install the hardware that we need to install for a seismic retrofit. Say a little bit about how these old houses are made. This floor joist, in fact all the floor joists, in fact all the wood in a house, all the frame material, that's all select structural. That's the highest quality wood you can get. So it's very strong, very straight, what we would call clear. And it's just fabulous wood. And these are all 2x8s or 2x10s, select structural. So this wood really has amazing qualities, and it's really top-notch stuff. You can't even split it if you try to. So that's what this is made out of. Right here you see an example of some, on the left-hand side you see wood, like the old style wood, the select structural redwood. And you can see how the growth rings are. You can barely tell, how close the rings are because they're just so close. And we've actually had times where we had to take a magnifying glass just so we could count the rings. So it's pretty amazing. Now the stuff on the right, that is from a tree farm. The old carpenters who built these houses that need retrofitting probably would have thrown that tree farm wood into the trash or turned it into firewood. From their point of view, it simply had no value at all. These old houses are made out of the select structural wood, the whole thing, the floor joists, the walls, the roof framing, all the framing is made out of that. That's pretty much all they had. They didn't have, tree farms like what you see here. We'd get 8 growth rings total in a 2x4. Here you'd probably see 15, 20, maybe 30 rings in a full dimension 2x4. So the wood that was used back then is very, very different. Practically a different species of wood. It doesn't split, it does amazing things. In fact, right now I want to show you a sample of some nailing where I nailed some 10-penny nails straight down a single grain, and there was absolutely no splitting. Right now, I would like to show you how a ledger is installed in practical terms. So here's our ledger right here, and the way these are first put together is you take a 2x8 or 2x12, whatever it is you're using, and you take that and then you outside of the crawl space in the front of your truck or in the yard or something, you cut it to size, and then you have to drill holes here for the bolts. So this is where all the bolts go. Now you take that whole assembly and you drag it underneath the house. Here's our access, and you normally have to drag it 48 feet. So you got to go all the way up here, and then you put it on the side of the foundation. Now the thing that you really need on the foundation is you need it to be pretty vertical. Otherwise, the floor won't fit, and then you also need it so it's not real bumpy. If a form broke or something like that, there's just no way to use this particular system. So what you do is you take your ledger and you have one guy hold it up on this side, another guy holds it up on that side, and then someone comes in and they put in all the bolts here in the middle. Now this is very labor intensive, so I would give that, I don't know, 10 man hours, depending on how bad the access is. So access is always a big problem. So as you can see here, this is a sort of a typical crawl space, a lot of things in the way. And if you can imagine, this usually weighs about 50 pounds. You got to get 2 guys, laying on their stomachs, crawling. and they have to drag that whole piece of wood to the front of the house. And then, like I said, you know, two guys have to hold it up, another guy has to put in the bolts. So putting these in is not simple. And contractors avoid putting these in as much as possible. Here's some photographs of ledgers that have been bolted to the side of the foundations. I'd like for you to notice that the foundation wall is vertical. If it's not vertical, then these things go in at an angle and they just don't fit like they're supposed to. So here, this one here is vertical, and then we come up here, and you can just imagine if this was not, you know, completely vertical, when you put this in, this ledger right here, when you bolted it, that hardware right there would be at an angle and it wouldn't work properly. So in this assembly right here, you have to have the foundation has to be flat and it has to be vertical. Now it gets pretty time consuming when you have to make one of these. This is a diaphragm on top of a wood member. And for these, we have to put this on there, you know, outside in front of our truck or something. So we nail this piece of plywood there. Then we attach it to the ledger right here. Then we drag the whole thing down 48 feet, and then again we have to hold it up. You know, again, takes three guys. One guy's got to nail it up into the joist. Other guys got to, you know, hold each end, and then they bolt it. So it takes quite a while. You know, the last time I quoted was 10 hours, you know, 10 man hours. It's probably a little bit less than that, but, you know, but not much. And so again, when contractors can avoid doing this, they always try to. And there is a method, as I mentioned previously, wherein you don't have to use a ledger. I showed this to a wood scientist, a PhD guy with Simpson Strong-Tie, and asked him, you know, to take a look at it and make sure it was code compliant, etc. And when he looked at it, he said, you know what, you're really pushing the code on this one. And what he said was that this joist right here, that actually could deflect a little bit, that it might deflect maybe 1 inch over 20 years if there's a piano on top of it. That's called a dead load. And so there's this hypothetical weight that's what the code uses, the hypothetical weight that goes on this joist, and over, you know, 20 years it's gonna bow a little bit. And therefore, he said that this was not code approved and it should not be considered for, you know, as a viable retrofit technique. So from my point of view, if you're going to save a client, you know, $1,500 by cutting out the joist like I showed you, and if it's not going to compromise the floor to any real extent, I mean, who cares if it bows, you know, after 20 years, and the probability of that actually happening is really small in the real world. This is all in engineers' heads. So I think if you look at public safety and you look at affordability, this is a very viable way to do that.